So we're going to do some more with order of operations, but we're going to also hearken back to what we did before in the previous section and do some substitution and kind of combine a whole bunch of stuff together. So I've got the absolute value of 5x minus 7y if x is 4 and if y is negative 1. So remember, we always start from the inside and work out. So I do know how to substitute. This is multiplication minus multiplication. So I'm going to go ahead and substitute in. So I've got a 5 times 4 minus 7 times negative 1. So this is multiplication minus multiplication. So I can take that and I can work it left to right. So I have that multiplication minus this multiplication. So 5 times 4 is 20 minus, and then 7 times negative 1 is negative 7. So now I've got minus a negative, so that's going to change into plus positive. So I'm still working in those brackets. And now I've got the absolute value of 27, which is positive 27. Okay. Let's try it again with 5x plus 4y in absolute values, where x is negative 8 and y is 9. So again, I'm going to substitute in for x and y. So I have 5 times negative 8 plus 4 times 9. Those are in absolute values. So I've got multiplication plus multiplication. So I'm going to do the multiplication first on each of them. So there's multiplication and there's multiplication. And then 5 times a negative 8 is negative 40 plus 4 times 9 is 36. So negative 40 plus 36 is the same thing as 36 minus 40, which is negative 4. So I have negative 4, and now I can implement the absolute values because I've done everything on the inside. So the absolute value of negative 4 is 4. All right, let's do a couple more. So a negative 6y plus x in absolute values over a negative absolute value of x if x is negative 8 and y is positive 8. So I have absolute value of negative 6 times y, which is 8, plus x, which is negative 8, and all of that's going to be over the absolute value of negative 8 with a negative out front. So I need to kind of sort of put this together and see what I've got going. I've got, I have multiplication and then addition here. So I need to do the multiplication first. So a negative 6 times 8 is a negative 48. And plus a negative becomes minus. And then over, so remember I can consider my denominator a separate grouping. So the absolute value of negative 8 is 8, and that negative is coming along for the ride. So the absolute value of negative 8 is 8, but this negative is on the outside, so he comes along for the ride. So negative 48 minus 8 is still in absolute values, and that's going to be a negative 56. And all of that is over negative 8. So now the only thing I've got left in my numerator is what's the absolute value of negative 56. It is positive 56 over negative 8. And now this is a fraction that reduces. So what is 56 divided by negative 8? 56 divided by 8 is 7, but my signs are different, so it's negative 7. Okay? All right, so we are now going to work on a new component, and that is the distributive property. And the distributive property is going to come into play if, pretty much, if there's nothing I can do on the inside, but there's multiplication on the outside. So what I have here is grouping symbols. So I've got a 16 minus 2m. Well, I can't do anything with that. So these are not like terms. These have m's and these don't, so I'm stuck right now. So there's nothing to be done on the inside, so let's move out a little bit. Well, now this is multiplication. So that 5 belongs to everything on the inside. So I'm going to take it and multiply it to both terms. So this 3 plus is going to come along for the ride. And then 5 times 16 is going to be 80. And then 5 times negative 2m is going to be a negative, because your signs are different. 5 times 2 is 10m. And from here, now I can combine like terms. So 80 plus 3 is 83 minus 10m's. Okay? All right, so we're going to distribute again. Negative 8 times q minus 2s. So the first thing I want to do is look on the inside. Is there anything that can be done on the inside of those parentheses? No, these are not like terms. And so there's nothing I can do within the parentheses. So is there something else I can do? There is. I can distribute that negative 8. So negative 8 times q, your signs are different, so it's going to be a negative answer, because that's a positive q. And then negative 8 times negative 2s. Your signs are the same, so you go positive. 8 times 2s is 16 s's. And that's as far as you can go. Okay, so I have negative 5 halves times y minus 4 minus 1/6 of a y. Okay, so I see grouping symbols. Look inside. Is there anything you can do? No, those are not like terms. You're stuck. So move out a little bit. Well, I can distribute that fraction to both terms. So I've got a negative 5 halves times a positive y. A negative times a positive is negative. 5 halves times y is 5 halves y. And then negative 5 halves times negative 4. A negative times a negative is a positive. And 5, remember, I'm going to go top to top and bottom to bottom. So that gives me 5 times 4 is 20 over 2 times 1 is 2. And instead of reducing that as I go, I'm just going to, for now, I am going to leave it and just do the top to the top and the bottom to the bottom. I'll reduce it in a second. This minus 1/6 y is kind of hanging off on the end. So this reduces to 10. 20 divided by 2 is 10. So I know that that's plus 10. Let's get him out of the way. So this part's done. Well, now I have this many y's minus this many y's. So these are like terms. The y is going to come along for the ride because you're counting how many you have. But I do need a common denominator. So my common denominator is going to be 6. So I'm going to go ahead and say negative 1/6 of a y. Well, this needs to be a negative something 6th of a y. So how do I change my 2 up here into a 6? I multiply by 3 on top and bottom. So that gives me a 6 on the bottom and a negative 15 on top. So negative 15 sixths of a y minus 1/6 of a y must be negative 16 sixths of a y. So negative 16 sixths of a y. And so really that y is just coming along for the ride. You're counting how many y's you have in terms of 6's. Okay, so then this reduces by what? By 2's. So I can divide the top by 2 and I can divide the bottom by 2, which gives me a negative 8 over 3 y's. Negative 8 over 3 y's. Now we're going to pause a second and talk about that. Because people get confused, why is this y out to the side? Because remember, I can write anything over 1. So I have a choice here. I could write this as a negative 8y all over 3. That is perfectly acceptable. I could write this as a negative 8/3 y. So it would tell me a fractional part of y. What I cannot do is write a negative 8 over 3y. That y is over 1. So either I can multiply it to the numerator, or I can just leave it outside, out to the right, whichever one makes you happy. And honestly, I flip back and forth depending on the context. So sometimes I'll write it next to it. Sometimes I will write it. Sometimes I'll write it next to it like this, and sometimes I'll write it up in the numerator like this. It just depends. Either way is right. All right. So now what do I have? I've got a negative 4/5 times negative 10y plus 30x, and then minus 20z. Okay, side note, I also put little slashes through my z's so you don't think that they're 2's. Okay, I'm not trying to be all fancy and crap. I'm trying to make sure you understand what I'm writing. All right, so I'm going to distribute this negative 4/5. There's nothing to be done on the inside because there's no like terms. So everybody gets a negative 4/5. And instead of me doing this in my head, I'm going to write it times each one. What I will do in my head is the sign change. So on this first one, I've got a negative times a negative is a positive. So this first term will be positive, and it's times 10y. Okay. The second term is a negative times a positive. Your signs are different. This will be a negative answer, and it will be 4/5 times 30x. My third term is a negative times a negative, which is positive, and that'll be a 4/5 times 20z. And now I can do this one of two ways. Either I can reduce first, so I could say that 5 and 5 reduce out of here and leave a 2. Or I can say that this is 40y's over 5. So 4 times 10 is 40 over 5 gives me 8y's. On this one, I could do negative 4 times 30 is negative 120 over 5, or I could do negative 24x, because 5 and 30 reduce to 6, and 6 times 4 is 24. The last one, 4 times 20 is 16. Oops, I just told you the answer. 4 times 20 is 80 over 5 is 16. Or you can reduce by 5s, and this becomes a 4. 4 times 4 is 16 z's. And that's as far as you can go. Okay? All right, so let's do a, that was a fraction one. Let's do a decimal one. So I've got negative 4.5d plus 4.4 minus 2d plus 0.2 plus 3.1d. So anything with a d we're going to put together. So my first question, is there anything I can do on the inside of those parentheses? Absolutely not. Second question is, what are they there for? I've got a negative 1 out front here. I'm just too lazy to write the 1. So I'm going to distribute that negative. And when I distribute the negative, it changes the signs. So I'm going to rewrite. So I've got a negative 4.5d plus 4.4 minus 2d minus 0.2 plus 3.1d. And now with decimals, I have a degree in math and I still think of money. Okay, so if I've got d's, they're going to go together. So he goes and he goes and he goes. If I don't have d's, they will go together. So let's put the d's together first. I've got negative $4.50 is what I have. I spend $2 more, so now I'm at negative 6.5 or 6.5. Then I add 3.1. So negative 6.5 plus 3.1 is going to be 3.4, and it's negative. So negative 3.4 d's. This is called the coefficient because it's attached to the variable by multiplication. It tells you how many you have. Okay. Now look at these. These are your constants. Okay, because 4.4 is 4.4 all day long. Its value never changes. Its value is constant. So if I have $4.40 minus 20 cents, how much money do I have? I have $4.20. And so now we have simplified that one. All right, a couple more because we're running late. All right, we've got 14/9 of a k plus 13/9 minus 2k plus 2/9 plus 2/9 of a k minus 6. So again, if it's got k's, I've got to put them together. So he has k's, he has k's, and he has k's. And notice when I'm boxing those up, the sign on the left is what goes with that term. Okay, so this one I know I'm going to need a common denominator. So, and it's going to have to be in terms of 9. So what would I multiply by to get a 9 on the top and the bottom? This will end up being a negative 18 over 9k. Okay, this one, I'll get to him in a second. All right, so how many k's do I have? I've got 14/9 of a k minus 18/9 of a k, because I multiplied the 1 by 9 and the 2 by 9, and then plus 2/9 of a k. So how much do I have? They're all in terms of 9s, and they're all in terms of k's. So 14 minus 18 is negative 4, plus 2 is negative 2. So I have negative 2/9 of a k. And then let's see if that reduces. It does not. Okay, so now let's go back up here. I've got 13/9 plus 2/9. And now this 6 needs to have a 9. So I'm going to multiply top and bottom by 9, so I get a negative 54. So 13 plus 2 is 15. 15 minus 54 is going to give me negative 39 ninths. Okay, so the last thing I've got to do is see if I can reduce anything. This is not reducible, but I can pull out a 3 from both of these. So I get a negative 2/9. And so negative 39 divided by 3 is negative 13. And 9 divided by 3 is 3. So that is your final answer. And then you can do that one, and you can do that one. So that is it for this section.